Okay, so we left off on Monday. We were talking about volumes and surface areas. We did like boxes and cylinders, irregular shapes, and stuff like that. I want to do just a little review problem, and then we'll get into some new stuff. Something like this. Let's say that this is 5 inches, 12 inches, and 20 inches. I want to know the volume and the total surface area. Let's do the volume first. What do we need to know to find the volume? Well, there was two things. Remember, we defined volume to be the area of the base times a height or some length or something like that, whatever connects the two bases. In this case, what is the base?
The triangle.
Yeah, the triangle here on the end. That's the base. So the area of that base is going to be found by doing what? Five inches times 12 inches divided by 2. Why is it divided by 2? Because it's a triangle. It's half of a rectangle. So that gives us 30 inches squared. Now to find my volume, it's the area of that base, 30 inches squared times 20 inches, which gives us what? 600 cubic inches. Yep. What's that? This volume? Exactly. And we're looking at it. Well, it's a three-dimensional measurement. Volume is a three-dimensional measurement.
Okay.
Yeah, like surface area. Area is a two-dimensional measurement. Surface area is a two-dimensional measurement. We're taking it in 3 dimensions, but it's still only a two-dimensional measurement. It only requires 2 dimensions to calculate. Now remember, surface area, we divide it up into 2 pieces. The area of the bases, which we've already found to be 30 square inches. And there's a second base, there's another 30 square inches. And the second piece of the surface area was the lateral area. And the lateral area required us to have 2 things. The lateral area is the perimeter of the base times the height. So what's the perimeter of the base? Well, here, to get the perimeter of the base, we need to know the length of that side, don't we? If I give you that that's a right angle there, that's this right triangle, how do I find the length of that side? I call that side x. A squared plus b squared equals c squared. Sound familiar? Yep. So 25 plus 144 is 169 equals x squared. So we need to square it. X is 13 inches. 13. Yep. So that means our perimeter of our base is 5 plus 12 plus 13, which is 30 inches. So our lateral area here is 30 inches, perimeter of the base, times the height of 20 inches for 600 square inches. That gave us the 13. But we still had to add that to these other 2 sides of the perimeter. So 600 plus the 30 and the 30 is 660 square inches. Because you got to add the bases. The 600 is just this rectangle, the bottom rectangle, and the back rectangle. We still got to add the bases onto the ends. So, what if we don't have a cylinder or a box or whatever? What if we have something that looks like this? I'll mark it like this so you know that it's a square base. Usually we're only going to work with pyramids that have square bases. We're not going to look at rectangular bases or anything like that. One of the reasons why I define volume to be area of a base times a height is because now when we get to the pyramids, it's just as simple. The volume for a pyramid is the area of the base times the height divided by 3. Because if you divided by 2, if you took a box and you cut it in half, you'd get a wedge. It wouldn't be a pyramid. Let me show you what I mean. So we have a box like this. If we cut it in half, we're just going to get this. A wedge. To get a pyramid, we'd have to cut it again. Like this. So it's less than half of the whole box. It ends up being 3 or a third. The way I remember it is in area is 2-dimensional. So to get from a rectangle to a triangle for area, you divide by 2 because it's 2-dimensional. To get from a box to a pyramid, you divide by 3 for volume because it's 3-dimensional. Yes, we don't get into 4th dimensional because I don't hate you. So the area of the base here is just going to be 16 inches by 16 inches. Otherwise known as 256 inches squared. Which means our volume, 256 inches squared times 15 inches of height, but we got to divide by 3. Multiply that out, that should give us 1,280 inches cubed is our volume. Do you concur? Okay. But you got to divide by 3. Surface area. It's still going to be the area of the bases plus the lateral area. The difference is there's only one base. So we've got the 256, but we're only going to use it once. We're not going to use it twice because there is no base on the top of this thing, just the bottom. Our lateral area. Still goes off of the perimeter of the base. But instead of the height on the other figure, since the sides went straight up, the height was the dimension of the sides. But here, the dimension of the sides really goes here at an angle. It's called a slant. So what we need is that slant, or sometimes called the slant height. To find that, it's not that hard. Make a right triangle here. We know this is just our height of 15. This here is just half of the 16, or 8. Since that makes a right angle, the slant is going to be 15 squared plus 8 squared equals that slant squared. If you figure that all out, you get 17 as the slant height. At this point, we've done enough of those. I'm going to assume you guys can square them and add them and square root them, right? Anybody need me to work through it?
Remember what happens when you assume? You see that?
Yeah, you get it wrong and you have to come back and do it next year.
Yeah.
Does anybody need me to work through that? Okay. So we've got a slant of 17. So it's going to be the perimeter of the base times a slant. And now all those shapes are not rectangles anymore, they're triangles. So divided by 2. Since we're doing with an area, it's divided by 2. So here, this is going to be the perimeter of the base, 16 plus 16 plus 16 plus 16, right? Perimeter of the base, 16, 16, 16, and 16, which is 64. My slant height, which I found to be 17 inches, and divided by 2, which is what? 544 inches squared. Add that to the 256 gives us 800 square inches of total surface area. Not so bad? What if we got a cone? Well, here's why I defined everything the way I did for the pyramid, because now everything on the cone is exactly the same. How do I find the area of the base? Pi times, that would be circumference of the base, perimeter of the base. Pi times radius squared. What's my radius? 5. So pi times 5 squared. Going to give us 78.5 square feet is the area of my base. So then my, what's that? What's that? Well, the radius is half of the perimeter, or half of the diameter, and 10 is the diameter. So our volume is the area of the base, 78.5 square feet, times the height of 12 feet, divided by, say 3. Give us 314 cubic feet of volume. What do you think? Still better than a sharp stick in the eye?
Sure.
Sure. No?
Yeah.
For surface area, we have the area of the base, the 78.5. We need the lateral area. Lateral area, let's see what we get here. The perimeter of the base for lateral area is going to be what? Pi times the diameter, pi times 10 will be 31.4. Slant height. Well, if I draw my triangle, this is 5, this is 12. So that slant height is going to be 5 squared plus 12 squared equals that slant height squared. 5 squared is 25, 12 squared is 144, that adds up to 169. Square root to get 13. So the lateral area, 31.4 feet times 13 feet. Divided by 2, because those are triangles. Gives us 204.1 square feet. Which is 282.6 square feet. Total area. What you think? I had to add the area of the base, which is the 78.5 to the 204.1 to get the total. Okay. The next step in geometry, we deal with what's called similar figures. What similar figures are is just where one figure is a enlargement or a reduction of the others. And we've looked at this a little bit before. We're just going to review it some right now. Where we might have a triangle. Let's try that again. And let's say that triangle gets enlarged. Like that. And let's say we have, what, 6, 8, and 12 here. And this side here becomes 9. Let's figure out what these other two sides are going to become. Well, if this is truly an enlargement or reduction of the other triangle, the ratio of each of the corresponding sides will be the same. So here we know that the 6 became the 9. So that's our first ratio. 6 goes to 9. If I want to find side x, what side corresponds to it? The 8. Is the 8 going to go on top or bottom? It's going to go on top because it comes from the same figure as the 6. So to find x, we're going to cross, multiply, and divide. 9 times 8 is 72. Divided by 6 is 12. So x has to be 12 units long. To find y, well, we still have the 6 and the 9 that go together. 6 still goes to 9. Y matches up with 12. The 12 goes on top because it's with the 6. Y goes on bottom. And we will cross, multiply, and divide. 9 times 12 is 108. Divided by 6 is 18. So y is 18 units long. This can be used even if the triangles aren't quite so simple like that, or shapes aren't quite so simple. We might have something like this. So let's see, this is 4, 10, 24. What's that? Oh, it seems to be, doesn't it? Is that a problem? Yes. Well, it is. It doesn't necessarily have to be in the same orientation, does it? How do we know for sure what matches up? Well, we look. You can see here I've got these angles marked as equal. You look for equal angles or corresponding angles. Once I know that these angles are corresponding or equal, we know that the 24 goes with the z because it's between the same two angles. See what I'm saying? So what we need to find is we need to find a pair of corresponding sides, one from each figure, where we know its dimension from both figures. Do we have that? The 4 and the 8. So we got 4 goes to 8. If I want to find x, is x going to go on top or bottom? Why is it going to go on top? Why does it go on top? It goes from the same figure as the 4. So it has to go on top with the 4. What goes below it? It corresponds to the 56. So we're going to cross, multiply, and divide. 4 times 56 divided by 8 is 28. X is 28. So, to find some of our other pieces, we still have 4 goes to 8. I want to find y. Y go on top or bottom? Why does y go on bottom when x went on top? Yeah, y comes from the same shape as the 8, so it has to go with the 8. What goes above the y? So it corresponds to 10. So if we cross, multiply, and divide, 8 times 10 divided by 4 is going to give us y equals 20. want you guys to find Z. So we start with the 4 goes to 8 again. Where's the Z go? Bottom, and what goes above it? 24. You cross multiply and divide. The Z equals 48. So simple enough. What would you ever use something like this for? Well, Cody, you want to volunteer?
Sure.
Okay, good. I was thinking, what am I volunteering for? Well, let's say Cody upset me. So Cody is going to get staked down to the ground.
Nice.
No offense, Cody. So he's staked down to the ground, and we're going to scare Cody just a little bit. We're going to go 40 feet away from Cody. And we're going to find a tree. Apparently a scrawny tree. And we're going to take this tree, and we're going to cut it down. It's going to fall towards Cody. We have no idea whether this tree is tall enough to reach Cody or not. But we do know that somewhere up here is the sun. And that sun shines down on our little tree. And it's making a shadow over here that is 60 feet long. We also know that I am exactly, I'll put it in a different color, I am exactly 6 feet tall. And the sun's shining on me and making me have a shadow that is 7 feet long. Well, that's looking pretty promising. My shadow's taller than I am, so the tree's got to be shorter than 60 feet. Cody's got a chance, right? So we need to know, what's the height of that tree? Is it going to reach Cody? What's it worth to you to not chop down the tree, Cody? Nothing? So what I have, I know that my shadow is 7 feet, and that compares to the tree's shadow of 60 feet. So I'm going to put 7 over 60. I could have put 60 over 7. It would not have mattered, as long as I match things up in the next part of this correctly.
Why? Oh.
Over here, my height is 6 feet. Does that go on top or bottom? Top. Why?
Because your shadow.
Yeah, because the 7 is my shadow, the 6 is my height. They have to go together. So below that is going to be the height of the tree, H. If we cross multiply and divide, 60 times 6 is 360. Divided by 7 is going to give us 51.42857,143 feet, approximately. So what does that say about Cody? You should have paid me off. Oh well. It's been good knowing you, Cody. If you die in the course of the class, it's an automatic pass, by the way, just so you know.
And then I just brush it off, come back, be like, thank you.
No. So anyway, we can use those similar figures like that are used in all sorts of things. If you get into map reading, the scale on your map, you get into, if you get into design drawings, like architectural drawings or mechanical drawings, it's your scale factors and stuff like that. Or even if you get into making toys, your 1 to 64 scale toys and stuff like that, it's the same thing. It's your scale factors.
I do that on maps, when you're trying to tell someone.
Yep. Yeah, that's exactly what it is, similar figures.
You're trying to travel somewhere?
Trying to?
I did a road trip to Arizona and I had never.
Okay, so.
It worked.
What though if we're not, that's if we're comparing lengths. The lengths are going to be proportional. What if we're not comparing the lengths? What if we're comparing the areas? So if I have, let's do this. I'm going to do a rectangle. Let's say I have a 3 by 7 rectangle. I'm going to enlarge it to be 6 by 14. What's the ratio of sides? The ratio of lengths here. Well, 3 became 6, right? Or reduces to a 1 to 2 ratio of lengths. Or 7 became 14, would also reduce to 1 to 2, right? But what's the area of this first one? How to find the area of a rectangle?
It's a 21.
21, 2 times 7. What's the area of this one? 84. Is the ratio of the areas 1 to 2?
Yes.
No.
No, because it's 8.
The ratio of the areas is 21 to 84, which reduces to a 1 to 4 ratio. Is there a relationship between those two? Possibly. Let's figure out what it might be.
Does that say area SE?
Area.
I don't know where the E came from. That should just be areas. I was trying to be Spanish or something. I don't know. Let's take a 2 by 9 rectangle and we're going to enlarge it to be 6 by 27. What's my ratio of lengths? Well, 2 becomes 6 or 9 becomes 27. Either one gives us a ratio of 1 to 3, correct?
Yeah.
What's my area here?
Down 18.
2 by 9 is 18. What's the area here?
162.
162. So my ratio of areas is 18 to 162, otherwise known as 1 to 9 if I use that. There's a relationship.
Yeah.
See, a 1 to 2 ratio of lengths became a 1 to 4. A 1 to 3 ratio of lengths became a 1 to 9. Anybody see the relationship?
I don't know. I was going to say it's a half of the.
It's squared. 1/3 squared. Remember, when you square a fraction, you square each number. What's 1 squared? 1. What's 3 squared? 9. If we did the 1 to 2 squared, what's 1 squared? 1. What's 2 squared? 4. So the ratio of areas is the ratio of lengths squared. So let's take a figure where we just can't directly find its area. Let's take a little figure like this. And let's blow that up. So let's say this starts out as 6 inches, and this has an area of 35 square inches. And this gets blown up to 10 inches, and I want to know what this area is here. Well, my ratio of lengths is going to be what? 6 goes to 10. If I wanted to, I could reduce that to 3 to 5, right? My ratio of areas is going to be what? 3 over 5 squared. What's 3 squared? 9. What's 5 squared? 25. That's my ratio of areas. Where's the 35 squared? Or where's the 35 go? Is it from the big figure or the little figure? Little figure, so it goes with the 9. So we shall cross multiply and divide. 25 times 35 divided by 9. Giving us 97.22. Inches squared. Pretty simple, huh? What do you think?
Can you move that down a little bit so you can see like the whole problem? Yeah.
Okay, so what if we have something like this? Where this was 8 centimeters, and it's going to go to 28 centimeters. And this area of this was 64 centimeters squared. And I want to find the area of this. Try that in your notes. Where do we start?
Well, 8 over 24.
We got a ratio of lengths is 8 over 28, which will reduce to a 2 to 7, right? Reducing it just makes it simpler. So for our ratio of areas, what do we do? Well, it's 2 over 7, and we're going to square it. What's 2 squared? 4. What's 7 squared? 49. So that's our ratio of areas is 4 over 49. Where's the 64 go? On top. So we should cross multiply and divide to get, but not everybody at once. What's that?
784.
Yes, 784.
I thought that seems wrong.
That'll be centimeters squared. What's that?
Squared 2 7.
Yep. I'm going to use that for the areas.
How did I not get that wrong? Because I just assumed since I didn't break down the 828 and the 27.
No, because you just have 64 over, what, 784. That'll be fine. That's the same ratio. It's more bigger numbers and harder to work with is all. But it's the same thing.
Crazy.
Volumes. Let's say I take a figure like this. And I'm going to cheat a bit. What's that? It's just a word. Yep. But it's got the ink tools installed with it. What's that? No, the whiteboard? Yeah, it is. So anyway, let's say this goes from being 10 inches tall to being 18 inches tall. And the volume of this here is 880 cubic inches. And I want to find the volume of this one. We're going to start out by doing the ratio of lengths again, which is 10 to 18, which I'll reduce to 5 to 9. For the ratio of volumes, I'm going to take that 5 to 9. Am I going to square it? No. What do you think I'm going to do? Cube it. 5 cubed is 125. 9 cubed is 729. So now, to find my new volume, I have 125 over 729. The 880, here goes the smaller one. And we shall cross multiply and divide. So 729 times 880 divided by 125. 5132.16. Inches cubed is the volume. Pretty simple? Yeah? Okay. Well, we're going to cut